Hello my scholars, you're welcome to my school YouTube channel. My name is Emmanuel. In today's video, we'll be tackling JAMB CBT past questions in chemistry for the year 2025. Please don't go anywhere, stick around and we'll be right back. You're welcome back to my school YouTube channel. In today's video, we'll be tackling question 26 to 50. Now, let's get down to question number 26. What is the molecular mass of an alkanoic acid if 0.5 mole of the acid weighs 44 grams? We're given moles, that's the number of moles we're given, and then we're also given the weight, which is the 44 grams, which is also referred to as the mass, okay? So we have mole, we have mass. So there's a relationship between number of moles and the mass, and the what? And the molecular mass. In other words, molar mass that we wish to find, okay? When you are trying to look at the relationship, we know that number of moles usually is equal to, of course, we are given that number of moles is 0.5 mole, and then we're also given that the mass is what? Is 44 grams, okay? And then we have to find what? Molecular mass, so which is capital M can handle that. So the relationship between these three is what you must be able to fix. So which is what? Number of moles is equals to mass over molar mass. So this is the formula for finding the number of moles in solid particles, okay? So we're given number of moles already to be 0.5, and then we know that our mass was given to be 44 divided by what? The molecular mass, which is the molar mass here. So which means M. Of course, if we make this over 1 cross multiply, that will be 0.5 M times 40 equals to 44. So when you divide both sides by 0.5, so we have M will be equal to 44 divided by 0.5. Of course, that's divided by half, okay? So that gives us 88 grams per mole, okay? That is 88. So the molecular mass of the alkanoic acid is actually what? 88. So we look at the options. We have the option A says 72, option B is 88, option C is 60, option D is 46. From what we had here, the correct answer is option B, 88. Now let's move on to question number 27. Alkenes are represented with the general molecular formula. Now don't forget that alkenes, okay, that's the unsaturated hydrocarbons. You know, we have the three common hydrocarbons that we have, okay, which other derivatives are from them. We have the saturated hydrocarbon, and then we have the unsaturated hydrocarbons, okay. The saturated hydrocarbons are the alkanes, okay, which are, we said the alkanes have the ANE, okay, and then they have the general formula CnH2n plus 2. Then we have the alkene, okay. The alkenes have the general formula CnH2n. There's no plus 2 with the alkenes. And then the alkyne, okay, what has the formula CnH2n minus 2. The alkanes usually are the carbon-carbon single bonds, okay. That's why we refer to them as saturated hydrocarbon. Saturated because there's no double bond, there's no triple bond. That's why we call them saturated hydrocarbon. While the alkenes are carbon double bond. We have them here, okay, double bond in between, and the alkynes are the carbon triple bond that we have in here, okay. So these are saturated hydrocarbons, these ones are unsaturated hydrocarbons, okay. So the general formula, you can see the molecular formula, general molecular formula for alkanes to be CnH2n plus 2, alkanes CnH2n, alkynes CnH2n minus 2, okay. So the question says alkenes are represented with the general molecular formula, alkenes ENE here, that is CnH2n. So you can see that option A says CnH2n, option B says CnH2n minus 2. This is the general molecular formula for the alkynes, okay, the carbon-carbon triple bond, and then we have CnH2n plus 2. That's the general formula for the alkanes, okay, ANES, alkanes. While CnH2n plus 1 OH, this is general molecular formula for what? For the alkanols, okay. We're asked for the alkanes, so the correct answer is option A, CnH2n. Now let's move on to question number 28. The major product when 2-methylpropene react with HCl is what? Okay, I think we can just draw the structure of this 2-methylpropene. Propene is the parent name, so we can start with that. Propene, that means that's 3 carbon atoms. So we have 1, 2, 3. Okay, and then propene, then we have 2 methyl propene, 2 methyl propene. So that means the double bond is actually on carbon 1, 2 methyl, or we can have it here, carbon 1, it can be from here or here. So 2 methyl, that means 1, 2 on carbon 2. That's where we have the methyl group, CH3. Okay, so this other one, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so we can draw this out now. Okay, this is actually the structural formula. So let's condense it. Let's make it condensed now. So we have CH2 here. Then we have bonded to carbon. Then that carbon has CH3 attached to it. Then we have double bond here. Then we have carbon here. Then we have H2. Okay, so this is your 2 methyl propane. 2 methyl. I don't know if you can see this well. Let me write it out very well. That's CH2, C, then in bracket we have CH3, bracket close, then we have double bond, then we have carbon here, CH2. Now, we are reacting this 2 methyl propene with HCl, so that means plus HCl. What product will be? What is the major product? Now, there's a rule, we call that Markovnikov's rule, okay, in organic chemistry. Markovnikov's rule states that whenever a hydrogen halide is reacting with hydrocarbon, especially the alkane or the alkyne, now the hydrogen from the hydrogen halide, let me use this now to explain. The hydrogen from the hydrogen halide is going to attach itself to the side, because you agree that this is a double bond. Okay, we have 2 sides to this double bond. We have this carbon atom here and then this carbon atom here. Now the 2 carbon atom in between where the double bond is, these two atoms are going to split, and then one of them will attach to one side, the other one attach the other one, which is the halide, the halogen itself, attached to the other one. So how do we know where each of them is going to attach to? So Markovnikov's rule says that the hydrogen is going to attach to the carbon atom that has more hydrogen atom, okay, while the halogen will attach to the side that has lesser amount of what? Hydrogen atom. So here what we need, this is carbon here, this is carbon here. Now this carbon atom has 2 hydrogen here. Now this carbon atom has no hydrogen at all, so which means this side has more hydrogen atom. Now once this is going to come, because this is what we call electrophilic addition reaction, okay, electrophile is adding itself to what? It's an addition reaction. So there's going to be an attack. Now the attack is going to cause this guy here is going to come in, and then this one is also, 2 of them are coming in, they will split. Now this bond is going to open. For this bond to open up, it becomes a single bond. But when it comes here, what happens? This hydrogen, because it has, this carbon atom has 2 hydrogen atoms here, according to Markovnikov's rule. The hydrogen from this hydrogen halide attaches itself to the hydrogen, the carbon atom that has more hydrogen atom. Okay, here now we have 2 hydrogen atoms here, but for this carbon we have methyl, not hydrogen. So there's no hydrogen for this. So this Cl now, which is the halogen, comes to attach itself to this carbon atom. Okay, let me bring this to this carbon atom, while this hydrogen comes to attach itself to this hydrogen atom. So once that happens, what here is what we are going to have. We have this CH2 here, then we have C here, then we have the CH3 in bracket. So the Cl that is coming in here stays here, which means it is together with this carbon atom that we have. Then we no longer have double bond again, we now have single bond here, because the double bond has been opened up by the electrophilic attack from this what? Halogen that we have in here. So we have Cl, then we now have this C will be here, then the H, it was 2 before, but this hydrogen adds to it, becomes what? 3. So what we have now is CH2, I think I can as well draw that, CH2, sorry, CH2, this is 1, sorry, this is supposed to be CH3, because 1, 2, 3, there should be 4. Each of the carbon atom must have 4 bonds, because carbon always have 4 bonds. So carbon is supposed to have, if you look at it, this is 1 hydrogen, 2, 3, and then 4. That's 4 bonds. So this carbon atom has 1, 2, 3, 4. That's correct. This carbon atom has 1, 2, 3, and then 4. So it's balanced now. So this is supposed to be CH1, 2, 3. CH3 here, then we have C here, H3 here, then we have that. So this is CH3. So we have hydrogen, hydrogen, hydrogen. We have drawn this. Then we have carbon connected. This is bonded to carbon atom. Then this carbon atom has CH3. That's methyl on that. Then the Cl is also attached to this carbon atom, Cl. Then we have this bonded to what? Another carbon atom, which is this. Then H3. We have 1, 2, and then we have 3. Okay, so this is the major product we are going to have when hydrogen halide, which is HCl now, reacts with what? With 2-methylpropene. So all we need to do now is let's give a name, the IUPAC nomenclature of this. So let's look at this. We have carbon 1, carbon 2, carbon 3. Yes? So on carbon 2, we have a functional group here. That's the substituent Cl. And then we have another one Cl. So the two of them are on the same carbon atom, number 2. So if both of them are carbon number 2 now to name it, first of all, in the IUPAC nomenclature, we start with the what? The parent name, the longest carbon chain. We have 1, 2, 3. We have 1, 2, 3. So we have 3. The longest is what? 3 carbon atom, which is what? Propane. Propane because we have just double bond, single bond, single bond. So it's no longer propane like it was. Now it is propane. Now the functional groups now that we have as substituent, we have chloro on 2 chloro. Then we have 2 also on methyl. Now alphabetically, methyl starts with what? Letter M, while chloro starts with what? Letter C. So alphabetically, C comes before what? Before M. So this is going to come first. So on 2, so that's going to be 2 because it's on carbon 2. 2 chloro, comma, then the other one is also on 2. 2 methyl propane. So the name is 2 chloro, 2 methyl propane. That's going to be the major product we are going to have here. 2 chloro, 2 methyl propane. So let's look at our option. The first option says 2 chloro, 2 methyl propane. 2 chloro, 2 methyl propane. Yes, that's what we have. So option A is correct. Option B says 1 chloro. If it is 1 chloro, it means this one is going to be on this carbon atom here. The carbon atom Cl, which is wrong, or here, which it should not be. This one is 3 chloro. If you say 3 chloro, that means it's going to be here, okay, or it's going to be on this side, okay, which is not what it is. But from what we have here, it is 2 chloro, 2 methyl propane. So the correct answer is option A. Now let's move on to question number 29. In the laboratory preparation of chlorine, the gas is passed through a wash bottle of water to do what? Now, during the preparation or in the laboratory preparation of chlorine gas, okay, while you are producing chlorine gas, hydrogen chloride, which is also a gas, is also produced along with it. But now it is an impurity because that is not our major aim. Now, because hydrogen chloride is impure, so we need to what? To eliminate, we need to remove that hydrogen chloride gas that is present in it as impurity. So in order to do that, we now run it through what? Water. The reason being that hydrogen chloride is highly what? Soluble. Okay? Its level of solubility in water is so high because when it dissolves in water, when it passes through water, it becomes soluble. When it's soluble in water, then it can now form the strong acid, which is hydrochloric acid. Okay? So, but the hydrogen chloride, which is HCl, is an impurity in this process. So we need to what? To remove it, to eliminate it. To eliminate it, we pass it through the water. That's why we pass it through the what? The wash bottle. So that as it passes through, it dissolves in it and it becomes absorbed. Okay? Once it becomes absorbed, then it can be what? It can turn to and then can be removed from it. So that is the essence of passing it through what? The wash bottle. If you look at option A, it says dilute it. Yes, of course, it's going to get diluted, but dilution is not the general reason for the setup. Dilution is not the general. The reason is so that it can get absorbed, like option B says, absorbs HCl gas. Yes, because HCl gas, that's the hydrogen chloride gas, is an impurity. So it needs to be what? To be eliminated. It needs to be removed completely from that so that we can have our pure form of chlorine gas. So once you add water, it becomes absorbed in it and then it dissolves in it and then it is removed as that. So option B is correct. Option C says neutralizes it. Yes, even though HCl can actually be neutralized by a base, okay, but the aim of passing it through, because this is the reason why we pass through the wash bottle is not to neutralize it, it's not to dilute it, but it is to what? To absorb it so that that impurity can be removed. And the only way to remove the impurity is to what? To absorb, pass it through water, the wash bottle water, so that it can be absorbed in it. It can absorb the gas and change it to water, and then it can be removed. Option D says absorb the chlorine gas. No, it's chlorine gas we need to produce. Okay, that's what we are producing, but it is not impurity, so there's no way you can absorb it in the wash bottle water. So it has to be absorbed by the what? It is HCl that is absorbed, okay, in the wash bottle water. So that leaves us with no other option than option B. So the correct answer is option B, absorb HCl gas. Now let's move on to question number 30. Carbohydrates can generally be represented by the general formula CxH2O for fructose. The value for X is what? For fructose, the value for X. Now you must understand that there are different types of carbohydrates. We can classify them into the monosaccharides, okay? We can classify them into disaccharides. We can classify them into polysaccharides, okay? Poly could be oligosaccharides and so on and so forth, okay? So, but the monosaccharides are the simplest form of sugar, okay, that we have when we talk about the monosaccharides, because we have about 6 carbon atoms. And then for the monosaccharides usually have the general formula C6H12O6. In that category, we have glucose forms in that category, is a monosaccharide. We have fructose in that category. We have the galactose, okay, and so on. We have so many of them, but these are the 3 common ones. For the disaccharides, okay, disaccharides, we have the C12H22 and then O11, okay. We have, that means 2 monosaccharides combined together to form disaccharides, okay. In that place, we have the lactose, we have the maltose, and then we have the sucrose, okay, and then we have the polysaccharide. Let's move on to now. This is where we are going to. We are asked that the formula here is for every of these, whether monosaccharide, disaccharide, and then polysaccharide, like where we have our starch, cellulose, and so on. But the question is, the value for sucrose here, fructose here, will be what? You can see that here. This is general formula. Now, if you have option A, says 3. If you have C3, then that becomes a triose sugar. Okay? But this fructose is actually exose sugar. Exose because it has 6 carbon atoms. It's a monosaccharide that has 6 carbon atoms. So if you add 3 here, that means it becomes C3H2O times what? Times Y. There will be there, depending on what Y is, but we are finding the value for what? Value for X. So it becomes a triose sugar, and that is not what fructose is. 12. If we have B, option B says 12. So if we have C12, that means we have to have H22 and then O11, then that makes it what? A disaccharide, and that also is not correct. Option C says 5. If we have 5, that means we have C5, then we have H10, but that's going to, because we have 5 carbon atoms, that becomes a pentose sugar. We say that is pentose, and fructose are not pentose sugar, they are exose sugar because they are 6 carbon atoms. And option D says C6. It becomes 6, that means C6, H12, and O6. So that is the right formula for fructose. So fructose as 6 carbon is exose sugar, which is a monosaccharide. So the correct answer is option D. Now on to question number 31. A gold bar and a silver bar are tied together firmly and left for years. Some of the gold particles will be found in the silver bar due to what? So if you have a gold bar, you tie it together, okay, with a silver bar. After a while, you leave them for a longer time, a long year, okay, for many years. Some of the gold, you discover that some of the gold particles, okay, will begin to form deposits, okay, on the what? On the silver bar. What is responsible for that? That's what the examiner wishes to do. Option A says Brownian movement. Well, if it had been Brownian movement, if there's a displacement of liquid, okay, we talk about a random movement of particles, okay, in fluids, whether in liquids moving in zigzag manner. But in this case now, we are talking about solids, okay, there's no liquid here. So option A, it's what is eliminated. Option B says diffusion. Well, diffusion is the movement of particles, whether solid particles, in from region of higher concentration to the region of lower concentration. So the gold bar actually is solid, okay, the bar is highly concentrated in that place. So on the silver bar is the place where you have little or no gold bar at all, the particles of gold on this one. But because they have stayed for longer time, they stayed for years tied together, begin to see the deposit of that what gold on that silver due to what diffusion. The diffusion is solid because the particles of that gold begin to diffuse. Okay, of course they are found in solid on the silver bar. You begin to find particles of that. So diffusion, yes, it can be. Let's look at another option. Option C says displacement. Displacement could be a general form of change in position. Okay, yes, that's what displacement is. There's a change in position, but that does not tell us what happens. That does not give account to the movement. Okay, what makes it move to that point? That is what we are looking at. Yes, displacement is a general term that because okay, this one has been able to move the particles, some of them have been formed here, but because it is not the entire gold that was found here, we have just some of it. Some of the particles were found on the gold, so it means that there has been a form of diffusion from the gold bar that is being highly concentrated to what, to a place where it is the silver, which is what, less what concentrated. So displacement also is eliminated. Then option D is the movement of particles, usually maybe in liquid too, from region of lower concentration to region of higher concentration through a semi-permeable membrane. So there's need for a medium to do that, but there's no medium that is taking. There's no semi-permeable membrane through which the gold is moving onto the what, the gold, the silver bar. So this also is eliminated. So we are left with no other option than option B, diffusion. So the correct answer is option B, diffusion. Now let's move on to question number 32. A metal that can be found in the free state in nature is what? So which means that it's not bounded together in ore. They are not found as ore. Okay, and such metals are called noble metals. Those metals are metals that are least reactive. When you find them in the electrochemical series, in the reactivity series, okay, they are usually at the bottom, okay, of that. So all we need to do now is let us look at the options we have. We eliminate the ones that are more reactive, and then we are left with two options. Now, if you look at these options we have here, we have silver. Yes, silver is less reactive. We have zinc. Zinc is highly reactive. Okay, iron is highly reactive, and then we have copper. More than that. So by default, we should have had silver and copper because it is two of them that we have at the underneath of that. And don't forget, we said metals that are found in free states, okay, are not found as ore. They are not found in this. For this zinc now, zinc can be found with zinc sulfide or zinc blend, okay, can be found in it. So you can find it in that ore of the zinc. So of course it cannot be zinc. Then we have iron. We can find iron ore, Fe2O3, okay, it can be found as hematite, okay, and then we can find it as the ore state. So that is not an element that can, a metal that can be found in free state. But these two, silver and copper, they are least reactive, okay, in the chemical series. So they are the noble gases. But because, of course, it could have been A or it could have been D. Those are the two options we have here. So we now consider the one that is less reactive between silver and copper in the electrochemical series. You agree with me that the silver one is actually beneath what? Copper here. So which means that the one we go for here now, the metal that can be found in the free state in nature is silver. So the correct answer is option A. Question number 33. Which of the following has the highest boiling point? Now, there's no point stretching yourself over this. So what we need to do first is look at the options we have. Now, when we talk about boiling point, usually, first of all, look for the ones that have hydrogen bonding, because compounds that have hydrogen bonding, that's the OH group, tend to have higher boiling points because of the intermolecular forces that hold that bond together. The stronger bond, the hydrogen bond, okay, you need a lot of energy to be able to break the bond between the hydrogen ion. So which means that look for the one that has the OH group, that's the hydroxyl group, first of all, so that is where you can have the hydrogen bonding. If you look at the options we have here, option A, we have OH here, yes. Then option B, we have Cl, we have no Cl, we have OH here. So we have these two, option A and option D. So option B and C, we can eliminate them. Now this one, yeah, this is chloro 1, 2, 3, chloropropane. That's what this is, okay? Now because of this chlorine here, yes, this is an halide. Then you look at this highly electronegative, but you look at this carbon atom, 1, 2, 3, 4, 5, 6. Now we have 6 carbon atoms here, which makes this is hexane. Okay, now hexane by default, if what we had in these options were CH2, CH3, CH2, and CH3, okay, without the OH here. And then this one is just also CH3. All of them are hydrocarbons, that there is no OH, there's no Cl here. This one that has the longest number of chain, longest carbon chain, okay, tend to have the highest boiling point because of the long carbon atom chains that we have in the bonded together, because it's going to take a lot of energy to be able to break that. But here it is just ordinary hydrocarbon, okay, that we have in here. So this one, yes, it has the longest carbon chain, but because of this OH here, this hydrogen bonding we have here, this one is eliminated. This one also, we have 1, 2, 3, just like this also, it has this. So this one also is eliminated because it has lesser what number of carbon atom here. Then we have this, even though we have chlorine here, but it makes it hard the least. So which means this one is going to have the least, okay, then followed by this. Now we have option A and option D now. Option A, we have CH3, CH2OH. This is ethanol, okay, and then we have CH3, CH2, CH2OH. That is 3 carbon atom. That is propane, propanol. So here is propanol, here is this. So both of them have hydrogen bonding, okay, here. So to break them, but now which one has the longer carbon atom chains? Now this one has 2 carbon atom. This one has 3 carbon atom. So this one that has 3 carbon atom tend to have higher boiling points, okay, than compared to this one. I think, yeah, this is propanol. Propanol has a boiling point of about 97 degrees Celsius or thereabout. Ethanol, we know that one, that is about 78 degrees Celsius. Then we have this is around 60, maybe 66 or 67 or 68 or thereabout, about 60 something, okay, Celsius. And then we have this one, just like this one has the least. So if you look at all of these ones now, based on the reasons we gave, propanol, which is option D, tend to have the highest what boiling point because of the what, the hydrogen bonding that we have here and the longer carbon what atom chain that we have compared to option A. So the correct answer is option D. Now let's move on to question number 34. We have a graph here. Here we have solubility here, okay, this solubility on this side, yeah, it's a bit blurred. That's solubility on this side, and then here we have temperature. Of course, when you have solubility against temperature, that is the solubility curve, okay, that we have in here. So here we have 20, we have 40, we have 60, we have 80, and then we have 100. So which means the temperature is increasing, and then from the origin, which is 0, and here we have 20, we have 40, we have 60, and then we have 80, and then we have this curve here, this slope here, this one is y, okay, then we have this curve moving here, that is x, and then we have this one going this way, that is z, and then we have this one moving here, okay, that's the last one, okay, that is this one. Okay, so now the question says, from the graph it can be inferred that, what can we infer? Option A says the solubility of X. Remember that in solubility has to do with the amount of solute that dissolves in a solvent, okay, at a particular temperature. So it is temperature dependent. That's why we have solubility here and then temperature here dependent. Now, the first option says the solubility of X and Y is the same at all temperatures. So let's look at that. Solubility of X and Y is the same at all temperatures. Let's look at X. Here is X here, okay, X moving this way, okay, and then we have Y here, this way, okay. So there's only a point of intersection here where both of them actually meet here, only at this point here. So which means this one, the temperature here and for this one are not the same at all points. It's only at this point they are the same. That's where they intercepted here, okay. So which means this first statement, that solubility of X and Y, because our solubility is what is increasing, what happens even our temperature is increasing, is not the same value as the one for Y also. X and Y, X this way and Y this way, so they are not the same. It's only at this point. So which means the first statement here is eliminated, is wrong. The second one says the solubility of X, Y, and Z is temperature dependent. X, Y, and Z is temperature dependent. Let's see X, yes. As X is increasing, solubility is increasing, temperature is also what? Increasing, yes. As Y is also moving, increasing. As temperature is increasing, solubility is also what? Increasing. But Z, we just discovered that it's what? It's just constant. So which means that solubility is constant. It means at 40, even though the temperature is what? Is increasing. As temperature is increasing from 0, 20, 40 to 80, the solubility remained at 40. So which means Z or Z is not temperature dependent. X and Y are temperature dependent, but this Z makes the statement to be null. So we cancel that out. We eliminate that. So we are left with option C and D. Option C says solubility of Z increases as temperature increases. Solubility of Z or Z, as some will say, increases as temperature increases. Now solubility is not increasing because it's at 40. Even though temperature is increasing, solubility remains at what, 40. It didn't rise to 50, 60, or it didn't rise to 42 or to 80. It just remained constant at 40. So solubility of Z does not increase. It is constant at temperature increase. So this also is not correct. Then option D is the last option. It says solubility of Y increases steadily as temperature increases. Solubility of Y increases steadily as temperature increases. So let's look at that. Solubility of Y, here is Y, here is increasing steadily, gradually. Solubility, you can see it is moving up, it's increasing gradually as what? As the temperature also is increasing, because from, you can see it from 20, it's moving on. At this point, if you trace this one down, this is around 65 or 70. So as temperature is increasing, solubility also is increasing. So which means option D is actually correct. So the correct answer is option D. Do you know you can take practice questions on a simulated JAMB CBT past questions? All you need to do is to click on the link in the description below that takes you to the Myschool website. There you'll be able to download the Myschool mobile app for your Androids and iPhone, and the Myschool software for your laptops and computers. Please go ahead and start practicing. Now let's move on to question number 35. The gas that is commonly used to demonstrate the fountain experiment is what? We have hydrogen chloride. Now, whichever gas that will be useful or commonly used to demonstrate fountain experiment must be one that is highly soluble in water. It must be very soluble. The level of solubility must be very high. Okay, and gases that are very soluble in water. Okay, we have HCl, that's hydrogen chloride gas. We have ammonia. Okay, those are gases that are very soluble when it comes to, they're highly soluble when it comes to solubility in water. Okay, option A says hydrogen chloride. Okay, in one of the questions we answered before, I think I explained what we're talking about in laboratory preparation of chlorine gas. Okay, we said which one is absorbed, and we said it is because HCl is absorbed. Now the reason being that HCl, that is hydrogen chloride, is highly soluble. In fact, once you pass it through water, it dissolves in it. Okay, it absorbs it and then it becomes soluble. Once it's soluble, it can now form a very strong acid, which is hydrochloric acid. Okay, which means hydrogen chloride is highly soluble. The level of solubility is very high. Option B says hydrogen sulfide. Now, even though hydrogen sulfide is also soluble, but it is not as soluble, okay, as we can have it with hydrogen chloride and ammonia. In fact, apart from that, hydrogen sulfide has a foul smell. Okay, it is a poisonous gas too. It is toxic, and it's also, because of that, it cannot be used to demonstrate the fountain experiment. Option C and D, that nitrogen 1 oxide and nitrogen 2 oxide, both of them are not as soluble. They have a low solubility level compared to hydrogen chloride. So among this option here, the correct answer is option A, hydrogen chloride. I believe you are enjoying this content. If yes, please don't forget to click on the like button, hit the subscribe button, and finally tap on the notification bell to keep you informed once we upload our next video. Now on to question number 36. Which of the following statements is false about hard water? Don't forget, hard water is a type of water that does not readily form lather, okay, when reacted with soap. When you use it to wash, that water that is hard will not form lather, will not lather at all with soap. And then we have temporary hardness and we have permanent hardness. In temporary hardness, you can remove that type of hardness by boiling, but permanent hardness is not removed by boiling. So now to this question, we actually talked about that in one of our video lessons in chemistry. So you can subscribe to our video lessons in chemistry, water solubility, so that you can have a better understanding of it. So, but for the sake of this question, say which of the following statement is false about hard water? Option A says helps animals to build strong teeth. Yes, this one is true, because we have the calcium ion, that's the calcium hydrogen carbonate, okay, and then we have the magnesium carbonate. So what makes it hard water is the calcium salts, okay, like the calcium calcium HCO3, Okay, we have 2, and then we have magnesium also, HCO3. Here we have 2 there. Then we have calcium sulfate, and then we have magnesium sulfate. So these 2 are responsible for, and the chloride, yes, and the chloride also, ion. These 2 are responsible for temporary hardness, while these 2 are responsible for what? Permanent hardness. But whether it is temporary or hardness, both of them have calcium and the magnesium salts. Now, this calcium, you know that it helps in building healthy, strong teeth, okay, and bone in humans and animals. So, hard water helps animals to build strong teeth. This statement is correct, but we are looking for the one that is what? That is false. So, this is a true statement. Option B says, cannot be supplied in pipes made of lead. Cannot be supplied in pipes made of lead. Yes, that, of course, is correct. That is correct, because this is false. When I say it's correct, it means it is false, because it is the soft water that cannot be supplied in pipes, okay? It is the soft water that when you supply them in lead can cause lead poisoning, okay? Lead poisoning, that can cause lead poisoning. So this one cannot be supplied in pipes made of lead. Hard water can be supplied, okay, to avoid lead poisoning. But when you say it cannot, that means that statement is what is actually false. Option C says tastes better than salt water. Of course, hard water, because of the presence of the ions we have in it, tastes better than soft water. So this statement is a true statement. And option D says helps animals to build strong bones. Of course, because of the calcium and the magnesium salt, like we have it building strong teeth, can also help to build strong bones. So this statement also is correct. But the only false, the statement that is not true, is what that is incorrect, is that it cannot be supplied in pipes made of lead. It is wrong. It can be supplied in pipes made of. So the correct answer is option B. Now let's move on to question number 37. The empirical mass of C6H12O6, this is a monosaccharide. Remember, we used this for the formula of fructose before. Glucose also has that formula, monosaccharide. C6H12O6 is what? Now, when we talk about empirical mass, we get our empirical mass from the empirical. We need to know the empirical formula first. And from our definition of empirical formula is the ratio, the simplest ratio, okay, in which the atoms of a compound combine together, the simplest. So it is not what? The whole number ratio. It is what? The simplest form in which atoms actually combine together to form that. Remember that empirical formula times n is what gives us molecular what? Formula. Because the molecular formula gives us the exact number of moles, okay, in the ratio, okay, whole number ratio in which they actually combine together. So we need what? The empirical what? Mass, or empirical formula first, because what we have here is actually the what? The molecular what? The molecular formula, okay? So to find the empirical formula first, all we need to do is we have C6H12, okay, let me put it this way, C6H12 and O6. Okay, we have a common factor here, which is 6, 12, and 6. So 6 is a common factor. So all we need to do, so we divide all this by 6, by 6, by 6. Let me write it this way to make it easier and clearer. Carbon has 6 moles, hydrogen has 12 moles, oxygen has what? 6 moles also from this. So we divide by the simplest here, which is by 6 common factor, 6 and 6. So this is 1, here is 2, here is 1. So we have C1, there's no point writing 1, that's the unit, H2, and then we have O here. So this is the empirical what? Empirical formula. Now we can calculate the empirical mass from the empirical formula. Remember, we are given that hydrogen is 1, carbon is 12, oxygen is 16. So carbon here is what? This is like saying C plus 2H, because that's H2. Then we have plus oxygen, just one of that. So this is carbon is 12, the mass is given here, plus 2 times hydrogen is 1, 2 times 1, then we have plus oxygen is 16. So by the time you sum this up, that's 12 plus 2 plus 16, so that gives us 30. So which means that's 30 actually. Now don't be distracted, okay, or don't get confused by just calculating this, because if you calculate this is actually the molecular what? Mass. So if you calculate this one, molecular formula, if you calculate this, you are still going to get an answer there. This is JAMB exam. They know that some students will just say, okay, here is 12. Let's try it. 12 times 6, okay, that's 72. plus 1 times 12, that's 12, that is 84. Then we have oxygen is what? Is 6, is 12, is 16, 16 times 6. What does that give us? That is 6, 3, that is 6, and then we have 3, that is 96. So 96 plus that, this gives us 10 plus 1, that's 180. 180, you can see there's an answer there, which is B. So a lot of students would have just said, okay, since we have this one, let me just multiply 12 times 6, this plus this plus this, because this is what? This is not the empirical formula. This is the what? Molecular formula for glucose. Okay, so but we ask for what? Empirical mass. So you need empirical formula to get empirical mass. That's why you must divide all to reduce this one to the simplest form by dividing all the 6, 12, 6 by what we did here to have CH2O. So this is what? The empirical what? Formula. Now we can now calculate the empirical mass from this by multiplying this and this. So which gives us what? This. So the correct answer is option D, 30. Now let's move on to question number 38. The nitrogenous compound in dead materials in the soil is converted to what? Okay, that process is called ammonification. Okay, of course, from the name ammonia, ammonification. So it simplifies it. So that has to do with microorganisms converting the nitrogenous compound. Okay, they convert them that is present in the material in the soil. They are converted into ammonia gas. Okay, now the ammonia gas eventually is what is now further converted by bacteria or microorganism or fungi into the nitrites and then eventually into nitrates in the process called nitrification. If you look at option A, ammonia is what is converted. Now in the nitrogenous compound in dead materials in the soil is converted to ammonia. Okay, that is what happens first. Option B says thiazonitrate 5. Thiazonitrate 5 is a process, of course, this is a nitrate. Okay, so which means first, it is the nitrogenous compound is first converted to ammonia. So in the process of ammonification. So after that, in the nitrogen cycle, what happens is that the ammonia that it was converted into now undergoes nitrification, where the ammonia is converted by bacteria into nitrites. Then eventually the nitrites are now converted into what? Nitrates, which gives rise to the what? Thiazonitrate 5. So which means option B is not the right answer. Option C says ammonium salts. Don't forget that ammonium salts are formed when ammonia are formed first in the ammonification, then it now reacts with water to now form the ammonium ion. Okay, which means ammonium salts are not formed first. Ammonia are formed first before ammonium salts. So this one is also eliminated. Option D says dioxonitrate 3. This is the nitrate also. So this one is also formed in the nitrification process, where the ammonia or the nitrates are converted into what? Into nitrate. So which is also this. So which makes this also not correct. So the correct answer is option A, ammonia. We are moving on to question number 39. The IUPAC nomenclature of the compound above is what? To make it easier, it's better to draw it out. This is the condensed formula, okay, of the molecular formula of this compound. So let's try to draw it out to make it easier. We have CH3 here. So we have the first carbon atom with 3 hydrogen. We have 1 atom, 2, and then we have 3. Now this carbon atom is bonded to this carbon atom. We have carbon here, just 1. Then we have triple bond, 1, 2, 3. Then we have another carbon atom here, 1. And then this carbon atom is bonded to this carbon atom, that is this, with 1 hydrogen here, that is this. Then we have CH3, 2 CH3 bonded. So 1 CH3 here, 1, and then the other CH3 here, 2. So that's the compound that we have in there. So I think it's easier now to name this. Okay, we have, we can go from either way, either from this 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. So if we go this way, 1, 2, 3, 4, 5, that's carbon atom 5. Or we go from here, 1, 2, 3, 4, 5, where we still have 5. The longest is 5. Or you go from here, 1, 2, 3, 4, 5. Okay, so this one now, we now give reference to the one that has the shorter the length. Okay, the distance from here 1 to 2, this is 2 here. The triple bond is on carbon 2 here, but from here 1, 2, 3, 4 is on carbon 3 here. So what we have now is this. So if we take it from here, 1, 2 here, 3, 4. So what we do is we go with the shorter one. This one is longer, 1, 2, 3 here. This is 1, 2 here, and then this is 1, 2, 3, 4. So we have this one is up. So we name it this way. So the first thing is what? The longest chain is what we are naming. This have 1, 2, 3, 4, 5. That is pent. So we have pent here. That is pent because we have triple bond here. And what carbon atom do we have that? Remember, we are naming from here 1, 2 on carbon 2. So that is going to be pent 2 because the triple bond is on carbon 2. Pent 2, and then this is what? Triple bond. And that means it is what? The alkyne. So it's going to carry this name YNE. YNE. So that is pent 2 ine. Now we look at what number of the substituent group do we have. We have one substituent group on this because we are saying 1, 2, 3, 4, 5. This is the straight chain. So this is the substituent group, okay, on carbon number what? Carbon number 4. Okay, this carbon 1, 2, 3, 4. So this is 4. So that is going to be 4. What? This is what? Methyl. 4 methyl pent 2 ine. Okay, so which means that we have 4 methyl pent 2 ine. If you look at option A says 3 ethyl but 2 ine. If you say but 2 ine, you are saying that the parent name, okay, is actually but. That means we have 4 carbon atoms. We are saying we have 1, 2, 3, 4, and then we now have the triple bond on carbon 2, which is here, yes. But with but is meaning we have 4 carbon atoms and we have 5 carbon atoms here. So which means option A is wrong. Okay. Then option B says 4 methyl pent 2 ine. 4 methyl pent 2 ine. That's what we did, and that is correct. Option C says 2 ethyl but 2 ine. For the way we have but 2 ine, we are saying that we have 4 carbon atoms, and that is wrong. For what we do, we have 5 carbon atoms, so this also is wrong. And then option D says 2 methyl pent 2 ine. If you say 2 methyl pent 2 ine, you are saying you are counting from here to be pent to be 2. So which means 1, 2. So you are saying the methyl group is on carbon 2. If you say that, then you should say here is 3, here is 4. So which means this cannot also be 2 methyl. If you say 2 methyl on carbon 2, then the triple bond cannot also be on carbon 2 here. Okay, it's supposed to be here, not here. So which means this also is wrong. So the correct answer is option B, 4 methyl pent 2 ine. Let's move on to question number 40. In the laboratory preparation of oxygen using potassium triisochlorate 5, tetrazomanganate 7, usually not recommended in modern laboratory because of what? When we talk about potassium triisochlorate 5, of course, it is a very highly oxidizable material. Okay, it is highly oxidizable. Okay, but option A says, why is it that, the question is saying, why is it that it is not recommended that when we are having the laboratory preparation of oxygen using potassium triisochlorate 5 and tetrazomanganate, when you are reacting together, why is it that it is not recommended that we should make use of potassium triisochlorate 5? Okay, option A says it forms because it forms explosive mixture with carbonaceous materials. Option B says it is explosive. Option C says it reacts with the catalyst. Option D says it is hazardous. Well, potassium triisochlorate 5 on its own is not explosive. Okay, cannot explode. But whenever it comes in contact with a carbonaceous material, when we say carbonaceous material that contains carbon, like we have rubber tubings, okay, like dust, okay, rubber tubings, okay, grease, even grease, okay, those things that contain carbon, that carbonaceous material, once it comes in contact with any of those things, it can react, it becomes sensitive, it reacts, and it can explode, it can cause explosion. So because in the laboratory you cannot rule out the fact that we can come in contact with dust, we can come in contact with maybe the rubber tubings or even grease from any of those apparatus that are used, and once it comes in contact with it, what happens? It is sensitive, it can explode. So on its own, it is not explosive, but it is when it comes in contact with those carbonaceous substances that it explodes. So to avoid that, in a modern laboratory, they are not recommended. So option A says it forms explosive mixture with carbonaceous material. So that is very much correct. So option B, I said it is not explosive on its own until when it comes in contact with this. So it is not B, it reacts with the catalyst. No, that's not what happens with it. Option D says it is hazardous, yes, but that is not why it is. On its own, it's when it reacts with that, it can explode. And anything that is explosive, it's hazardous and it can cause harm No, in the lab we try to avoid that. So the correct answer is option A. Question number 41. The type of bond between copper 2 tetramine and chlorine in this is what? Now if you look at this compound, this is a complex compound. This is actually from, we have CuNH3, okay, 4. This is a complex on its own, complex ion, which is 2+, and then we have Cl2. So which means that the bonding is actually, we say it's ionic bonding, okay, it's ionic compound. It's ionic compound because it is formed between, this is a positively charged complex ion, and then we have the what? The negatively charged ion. So we have 2 of this Cl minus, okay, chloride ion, we have 2 of that here reacting or bonding with what? This positively charged ion that we have here. So this is positively charged, then we have negatively charged ions that are combined. So that is ionic. So this ionic compound that is formed from this ion and this ion. So it is, if you look at option A says dative. Yeah, dative and or what we call coordinate covalent bond. That is what happens in here, okay, between this itself, because we have 4 of this ammonia, okay, reacting with this. So here inside of this complex ion itself, okay, we have dative bonding, but we are talking about the entire compound here. Van der Waals forces and then the Van der Waals bond and then the covalent bond are not, what is actually responsible here, because we have, these are the ions here, and then we have what we call, there is a transfer of electrons, okay, from this to actually to this. So we have this transfer, there's bonding between positively charged ions and negatively charged ion, and that, of course, we know it is ionic compound that is formed here, and ionic bond actually exists in ionic compound. So the correct answer here is option C, ionic bond. Now on to question number 42. We have a chemical reaction here, that's magnesium metal reacting with 2 moles of hydrochloric acid to give us magnesium chloride here, and then we have hydrogen gases. Of course, when a metal reacts with an acid, hydrogen gas is liberated. That is a reaction we have, one of the chemical properties of acids. In the reaction above, magnesium is a reducing agent because of what? Option A says oxidized, option B says reduced, option C says a metal, option D says a solid. Well, all metals are reducing agents actually, but in some reactions, they can behave as oxidizing agents and they can also behave as what? As reducing agents. So that is not the reason, but let's look at this critically. We have magnesium here. First, let's consider the oxidation number, oxidation state. Is there an increase or a decrease? We have magnesium. What is the oxidation state of magnesium here? That is 0, because this is an element in its free state. So the oxidation state is 0. Then we look at what we have on the right hand side. What is the oxidation state of magnesium here? So magnesium here plus chlorine is actually -1. That's the oxidation state of -1. But we have 2 of it here. So that means times 2 equal to 0. So that means magnesium will be plus times minus is minus, 1 times 2 is 2, so -2. When you cross it to the other side, it becomes what? +2. So which means from 0 to +2, that's what? An increase in oxidation state. Now, take note, reducing agents will undergo oxidation, while oxidizing agents will undergo reduction. I will say that again. Reducing agents will generally undergo oxidation, while oxidizing agents will always undergo reduction. So it is what it is. So all we need to do now is let us see where oxidation is taking place, because the question says that in the reaction above, magnesium is a reducing agent, because so reducing agent will undergo what? Oxidation. It means reducing agent will be oxidized. So let's look at this. Oxidation now has taken place because from 0 to +2, because we said that oxidation is increase in oxidation number, or oxidation is what? Loss of electrons. So magnesium is losing 2 electrons here, of course electrons here, to become what? To become oxidized. Oxidation is loss of electrons. So magnesium loses 2 electrons to become oxidized here, or there's an increase in oxidation number from 0 to +2. So which means that this magnesium is a reducing agent because it is oxidized. So option A says oxidized because it is oxidized. Yes, that's correct. Option B says reduced It is not reduced because it's oxidized. If it is reduced, we would have had a decrease in the what? In the oxidation state of magnesium. It is not because it's a metal, because we have some metals that can also act as oxidizing agent depending on the type of reaction, especially when you have two metals reacting together. Okay, so one can act as reducing agent. So it's not because it's a metal, that is why we have it as that. Though we know that generally metals, especially those ones in group 1 and group 2 metals, are reducing agents, but we have reactions where we have two or more metals reacting together. So one will definitely reduce while the other one will be oxidized. So, but that is not the reason why, and it's not because it's a solid. This is just a state of matter. Does not determine if it's a reducing agent. So the correct answer here is option A, oxidized. Now we are moving on to question number 43. An example of a physical change is, we have option A, addition of water to calcium oxide. If you react water with calcium oxide, that's a quick line. If you react it with water, we are going to form, that is calcium hydroxide. Of course, this is a new substance, and we know that new substances are not formed in physical changes. New substances are only formed in chemical changes, okay, and they are not easily reversible. So addition of water to calcium oxide is a chemical change, so this is not correct. We have corrosion of iron. Now iron can be corroded when we have iron reacting with oxygen, and then in the presence of moisture, oxygen react with iron, rusting takes place. So we have corrosion here. So if we have that taking place, we are going to form rusting. So, and rust is what is going to be a new substance entirely, and it's not easily what? Reversible. We cannot take away our oxygen, we can't take away our moisture from that rust. Okay, once it's formed, it's formed. So that is a chemical change. So this also is eliminated. Option C says dissolving sodium chloride in water. If you have sodium chloride, you dissolve in water, salt, solute react with solvent to form solution. Okay, we have a salt solution. That salt solution, of course, even if the salt becomes dissolved completely, if you apply heat to it, you can still get our water back, and we can still get our salt back. Crystals of what? By what? Crystallization. We can have that taking place. So which means, since a new substance is not formed and it is easily reversible, so it means this is what? A physical change. And option D says burning of charcoal. If you burn your charcoal, of course, that is combustion. Okay, it's a rapid reaction. What happens? We form ashes, and then you can't get those ashes back and then to form your charcoal back. So this is a new substance is formed. So this is also a chemical change. So an example of a physical change here is dissolving sodium chloride in water. So the correct answer is option C. Now let's move on to question number 44. When a sample of air is passed through alkaline pyrogalol, potash, and finally through a U-tube containing fused calcium chloride, the components of air left unabsorbed are what? Don't forget that air, we say, is a mixture of gases. And then when we dealt with that in one of our video lessons in chemistry, where we talked about air as mixture of gas, you will also agree with me that air comprises, we have oxygen, we have nitrogen having about 78% in composition, we have oxygen about 21% in composition, we have noble gases there, we have nitrogen, we said that before, we have water vapor also. All of those ones are all together in air. Okay, so now we're told that that sample of air was passed through alkaline pyrogalol. So permit me to just draw here that this represents the mixture, okay, which is air. Now it was passed through alkaline pyrogalol. Now, don't forget, inside of this air, we said we have nitrogen here, we said we have oxygen here, we said we have water vapor, okay? Then we said we have noble gases. Noble gases, that's N-O-B-L-E. Noble gases, yes? Here, and we have impurity in here. Now, when you pass this air through the alkaline pyrogalol. Now, the alkaline pyrogalol, usually we absorb no other gas than what? Oxygen. So, what alkaline pyrogalol is coming for here is not nitrogen, it's not water vapor, it's not noble gases, it's this guy here. So, which means that the alkaline pyrogalol will absorb this oxygen from air. So, we are left with nitrogen, we are left with water, we are left with what? Noble gases. Now, we are done with this. The next one is potash. Potash here has a tendency to take away. Oh, I didn't include, we have carbon dioxide. Carbon dioxide is also there, because when I saw this potash here, potash is only coming for no other one than what? Carbon dioxide. Carbon dioxide, carbon dioxide, we are saying the same thing. So potash comes in here into the same setup, and then it absorbs, it deals with this what? This carbon dioxide, carbon dioxide, and so we are left with nitrogen, water, and we left with what? Water vapor, and then noble gases. Then we went on to say, and finally through what? U-tube containing fused calcium chloride. Now the fused calcium chloride is a drying agent, okay? Drying agent, so it dries gases. So what it does is it just comes in here, and then this water vapor that is here, the fused calcium chloride takes care of it, because this is what? This is a drying agent, okay? It takes care of it. And then we have said the components of air left unabsorbed are, we have what? Nitrogen here, we have noble gases. So let's look at that option. Option A says we have nitrogen and carbon dioxide. Carbon dioxide already has been dealt with potash, so we have left with nitrogen is correct, but this makes this not to be correct. Option B says noble gases and carbon dioxide. Noble gases, yes, but carbon dioxide also makes this option to be eliminated. Option C says we have noble gases and nitrogen. We have noble gases here, we have nitrogen here. That is left in the air. Yes, that is correct. And option D says noble gases, nitrogen, and carbon dioxide. So the inclusion of carbon dioxide here makes this option also to be null. So the correct answer is option C, noble gases and nitrogen. Do you have any question bothering your mind at all on all we have done so far? Please feel free to ask a question. All you need to do is to click on the link in the description below that takes you to the Myschool website. There, you'll be able to ask your questions, and solutions will be provided within the shortest period of time. Now, let's move on to question number 45. An atom of element with the configuration 1s2, 2s2, 2p6, 3s2, 3p5 is likely to belong to what group? Group 7, group 5, group 2, group 3. For me, what I do to make it easier is to identify the elements. This configuration is not too much that you cannot identify. So all we need to do is we're going to sum up this, okay, this superscript. This number is superscript. That's what shows the what? The number of what? Electrons that we have. So I have that 2 plus 2 here, that is 4. 4 plus 6, that is 10. 10 plus 2, that is 12. 12 plus 5, that is 17. So which means what element in the periodic table is having atomic number of 17? There's no other one than our friend chlorine. So chlorine has atomic number of 17. So I ask myself, in what group in the periodic table is chlorine? Chlorine is actually in group 7 element. You can also try to write this alternatively, 17. So I can write that the first shell is 2, second shell is 8, third shell is 7. So 7, it means it's in group 7. So that settles it. So there's no much ado. Don't waste your time here. Not group 3, not group 2, not group 5, group 7. So the correct answer is option A, group 7. Do you have better steps or solutions to all the problems we have solved so far? Please feel free to share with us. All you need to do is to go to the comment section, indicate the question number and the solution you wish to share with us. Now let's move on to question number 46. A molecule with a polar covalent bond between atoms exhibit what? Now, when we talk about polar covalent bond usually takes place between atoms that have a significant difference, okay, in electronegativity. The difference is quite much, okay. Atoms that have difference, a quite long range, okay, in their electronegativity levels. Now, when we talk about the molecule with a polar covalent bonding between atoms exhibit, we need to also understand what electronegativity is, okay. Remember, molecule with a polar covalent bond, like I said, polar covalent bond exists between atoms that have significant difference in their electronegativity. And electronegativity is the tendency, the ability of an atom to attract shared electron to itself. Okay, that's what electronegativity is. Now, when the bonded, I'm explaining what happens with the polar covalent bonding. Now, when the electronegative, the bonded shared pair of electron, because option A says unequal sharing of electron pair. Now, electron pair now is the bonding that is taking place between the two atoms. Now, don't forget that polar covalent bond is taking place between two atoms that have significant difference in electronegativity. So electron pair, okay, in the bonding, okay, that takes place between the two atoms tend more closer to the one that is highly electronegative. So it brings it closer, and that is actually what accounts for the unshared sharing, the unequal sharing of electron pair, because the one that is highly electronegative tends to draw more, the bond tends towards that side, so it spends more time closer, okay, to the highly electronegative atom, while the other one that is lesser electronegative atom that is bonding, it moves away from it. So it spends more time, because it spends more time closer to the one that is highly electronegative, it accounts for the unequal sharing of the electron pair. So which is what option A says, unequal sharing of electron pair. Option B says equal sharing of electron pair. If it is equal sharing of electron pair, then it becomes a non-polar covalent bond, okay, because it means that the sharing is equal. So no one is highly electronegative than the other one, and that one usually takes place in molecules that are the same. When I mean like oxygen molecule O2, so oxygen and oxygen, okay, we have it there, so which means two of them, no one is, the bonding is not tending towards anyone than the other, because they have the same electronegative. So in this case now, this one becomes a non-polar covalent covalent bonding, so which means this is not what we are talking about. Option C says equal sharing of electron lone pair. When we say electron lone pair, this is not taking place in this, because we are talking about electron lone pair. Lone pair, it means that the one that is not taking place, it is a non-bonding electron that is taking place. So which means this one also is not an unequal sharing of electron lone pair. So lone pair is the pair of electron that is left that is not bonding, but we are talking about polar covalent bonding, the one that is taking place in bonding, okay. So which means that the correct answer here is option A, on equal sharing of electron pair. Now let's move on to question number 47. We have magnesium here plus lead ion to give magnesium ion plus lead here. So what is the cell notation for the cell reaction above? Now when we want to write the cell notation for this, first we identify where oxidation is taking place, and then we identify where reduction is also taking place. Now where oxidation is taking place usually is with the anode, and then while reduction is taking place at the cathode. If you look at this, we have Mg plus Pb2 plus. Now let us identify where oxidation is taking place. Remember, oxidation is what? Loss of electron, or oxidation is what? Increase in oxidation state. Now let's take this first man here, this guy here. Magnesium here has oxidation number of 0. Then let's look at what it has here is plus 2. From 0 to plus 2, that is an increase. From 0 to plus 2, that's an increase in oxidation state. So this is what? Oxidation. Okay, so this is what happens at the at the anode. So we write that usually on the left, and then this other one now is from plus 2 here, okay, to what? To 0. Here is 0, here is plus 2. There's a decrease in oxidation state here, plus 0 to that. So this one is what? Reduction, and this one is always at the at the cathode. So if you are going to write that, what happens first? At the anode, that's where oxidation takes place. So it means that magnesium here is going to lose 2 electrons. Okay, so it becomes Mg2 plus 2 electrons that is lost there. And then at the cathode, we shall have, and then when we want to represent this now, if you are writing this one in cell reaction notation, now cell notation is going to be Mg first, then you have slash, just like a stroke like that, that is straight up, then we have Mg2 plus. Okay, that's what happens here. Then at the cathode, what happens there is what? Reduction. Reduction is with the other guy, which is what? Lead. So lead ion, we have lead 2 plus. Reduction is what? Gain of electron. Reduction is gain of electron, Rig. Okay, so that is 2 plus. Then we have 2 electrons here to give us Pb. So if you are going to write this one notation, it's going to be Pb 2 plus. then we have slash PB here. Now we are going to add the two together now. Remember, oxidation is always at the left, so this one comes first. So it adds Mg slash Mg2 plus. Okay, then we have a double slash like this, like a salt bridge, okay, to differentiate, to separate the two from each other. So the second one is here, PB2 plus slash PB. So all we need to do is let us look at what we have in the options and then we go for it. We have Mg slash PB. Okay, no, Mg is not oxidizing to lead. No, so that is wrong. Magnesium is oxidizing to magnesium ion. Okay, this means magnesium is losing electron to become Mg2 plus, and this is also saying lead is losing 2 electrons to become lead2 plus. No, we can't have oxidation taking place in these two. Oxidation must take place in one while reduction takes place in the other. So this also is wrong. Option C says magnesium undergoes oxidation, loses electron to become Mg2 plus, and lead2 plus, of course, gains electron to become lead here. So which means Mg plus, and then we have slash this. Okay, so which means this is correct. And then we have this other one, magnesium loses 1 electron, okay, to become this. It's not 1 electron. Magnesium is divalent. From what we have here, this is Mg2 plus, so it cannot be 1 positive and 1, so this is off. So from what we just have here, the correct answer is option C. Question number 48. The correct arrangement of gases in the order of increasing rate of diffusion is what? This is Graham's law of diffusion coming into play here. One of the laws we treated under the gas laws, okay? And then what does it say? Graham's law of diffusion states that the rate of diffusion of a gas is inversely proportional to the square root of the molar masses, okay? Or the vapor density. So, which means that if the rate of diffusion is inversely proportional to the square root of the what? Molar mass, so it means that the gas that has a higher molecular mass, when you calculate your molar mass, we have a lower rate of diffusion. So which means the higher the molecular mass, the lower the what? The rate of diffusion. And the lower the molecular mass, the higher the rate of diffusion. So now it says that the correct arrangement of gases in the order of increasing. So if it is increasing, it means we are going from what? From the smallest to the what? To the highest rate of diffusion. So, and if we are going from the smallest to the highest, it means that the one that has the highest molecular mass will have the least. So we have to arrange now. We calculate the molecular masses of each of these gases one after the other, and then we now look at the one that has the highest molecular mass, followed by the smallest, followed by the next, followed by the next, till we have the smallest. Okay, it must follow in that range. So let's look at the first one. We have carbon. Of course, all these numbers I believe you can calculate that by now. Carbon is 12. 12 plus oxygen. Oxygen is 16 times 2. 16 times 2 here is 32. 32 plus 12 here, that's 44. So here is 44. Okay, comma, then hydrogen is 1 times 2, that is 2, comma, SO4, sulfur is 32, 32 plus 16 times 2, 32, that's 64 here. Then we have carbon is 12, 12 plus 16, that is 28, 28. Of course, you can see this one does not follow in increasing order. We have 44, so if we had 64 here, we would have followed that. So 44, 2, 64, 28, so this actually is wrong. Let's look at the second one, SO2. That's 64. We did that already. So that's 64 here. Comma. Oxygen is 16 times 2. That's 32. That's 32. Followed by ammonia. Ammonia is nitrogen is 14. Then this is 7. 1 times 3 is 3. That's 17. So here is 17. Then we have hydrogen. 1 times 2. That is 2. Okay. This one is highest. Followed by this. Followed by this. Followed by this. So this definitely should be the most appropriate. Let's look at this. Of course, there's no time. Once you have seen this, just go ahead and pick your answer. But for benefit of doubt, okay, let's look at this. This is ammonia. Ammonia is 17. Okay, followed by nitrogen is 14 plus 16 times 2 is 32. 32 plus 14, that gives us 46. That's 46. And then nitrogen is 14 times 2, 20. There's no point wasting time because this one is smaller, this one is higher, then this one is smaller again. So definitely it can't be this. This is CO2, that's 44. 64, then ammonia is 17, oxygen is 32, and then we have 64. So we have this higher, this lower, this higher. So if you look at it, which means from the highest. Now, this has the highest molecular mass or molar mass, followed by this, followed by this, followed by this. So which means that this one that has the least will be the highest what? Highest rate of diffusion. Hydrogen has the highest rate of diffusion here, followed by ammonia, followed by oxygen here, followed by what? SO4. So which SO2. So which means that this one has the least rate of diffusion, followed by this, followed by this. So this one has the highest. So in form of in increasing rate of diffusion, it is this. So the correct answer is option B. On to question number 49. In a series of solutions with pH of 2.5, 3.5, 7.0, and 8.0, which is likely to turn red moist litmus paper blue? So you ask, which substances turn red litmus paper to blue? That is alkali. Those are bases. So what we'll be looking out for now is which one has a pH scale that is basic. Remember that on the pH scale from 0 to 14, okay, remember that this point is 7. From 0 to less than 7, this is acidity, okay, that's acidic, while from 7.1 upward to 14, between 8 and so on, this is alkaline. So it's only alkaline that actually what? That has values that are on the pH scale that can what? That can change. It is alkaline or basic that can turn red litmus paper to blue. That is one of the physical properties of bases or alkali. You say we turn red litmus to blue. So which means that the examiner is asking that which among these ones is alkali in nature. Option A says 3.5. 3.5 falls in between this range, so which means it's acidic, so that cannot be. Remember, we are looking for the one that is alkaline in nature or basic. Option B says 8.0. 8.0 falls in the alkalinity, okay, alkaline region, so that is correct. Option C says 2.5. 2.5 is acidic. Option D says 7.0. 7.0 is neutral. It's neither acidic nor basic, so that is off. So the correct answer is option B, 8.0. Now question number 50. The process by which iron corrodes is what? Corrosion is a way of rusting, okay. Option A says rusting. The process by which iron corrodes is what? Rusting, because that process, the iron reacts with oxygen as well as moisture. Once it reacts with oxygen and moisture, what happens? Rust sets in, and once rusting takes place, say it is rusting. Of course, that's a chemical change, so it is corrosion. So iron corroding is also known as rusting. Option B says burning. And don't forget that this iron corrosion or this rusting is a gradual process, okay? But burning is a rapid, in fact, combustion. It's a rapid reaction, okay? You burn it and then everything gets down into this. So burning is not the process of iron corrosion, but rather burning the iron just reacts with oxygen, okay? And then when it reacts with oxygen for complete combustion, it's usually the products are not what we have as iron corrosion. And option C says galvanizing. In fact, galvanizing is a way of protecting the iron. Maybe you coat it with another metal, okay, to prevent it from corrosion. So galvanizing is a way of preventing the iron from undergoing corrosion. And why option D is alloying, adding another element of metal to iron to maybe increase the quality and also to make it not. So among this option now, the correct answer is option A, which is rusting. I believe you enjoyed this content because I really did while I was solving that. Please don't forget to click the like button, hit the subscribe button, and finally tap on the notification bell to keep you notified once we upload our next video.